If you're a TypeScript developer and you want to leverage your TypeScript skills to get a head start learning Go, well, in this video, I'm going to show you the basics of the Go language. I'm going to show you how to structure a Go project. And finally, I'm going to show you how to write some basic unit tests for your Go. So why should you learn Go? Well, firstly, it's for the same reason you should learn any programming language. It's fun. And then secondly, it's fast, it's easy to learn, but it's also very difficult to master. It's going to take you years to master Go. And then finally, you can get some great paying jobs with your Go skills. The structure of this video is going to be a little bit different. So firstly, we're going to go over the basics of a to-do application. I'm just going to walk you through the code and ease you into it. Secondly, we're going to refactor that to-do application so you can get a good idea of how we're going to structure our application. And then finally, we're going to build and test a URL shortener. So this URL shortener application that we're going to build is going to be very simple, but I want you to take that application, turn it into something of your own, and then put that in your portfolio. All the code that you're going to see in this video is going to be in a GitHub repository, and you'll find that GitHub repository in the link below. And then finally, if you haven't subscribed already, make sure you hit that subscribe button. This video has taken me hours to create, and that button will take you just a second to click. So let's dive in to learning some Go. So let's have a look at our file tree here. So the first folder we have is our CMD folder here. Now you don't have to put your main file inside of a CMD folder, but it is typical, and that's what we're going to be doing throughout this tutorial. Secondly, we have this Go mod file, and the mod file is going to include the modules that we use throughout this application. So this is like your package.json. So firstly, we described the module that we're working in now. Now this is a path that you need to define when you initialize your project. Then this Go version here is the version of Go that this project is intended to be run with. You can see that this Go version here matches the Go version that I have down the bottom here, and this is going to ensure that when I run this application locally, it's going to behave the same in production. And then finally, we have a module that we're requiring. So you can see here, I have Go Chi, and this is a router just like Express or Fastify or Koa, for example. And then we have the version that we're using of that module. And then finally, we have this sum file here, and this includes our Go Chi, and it also includes a hash of the package here. So you won't need to touch the mod or the Go sum file. You'll only be working in Go files. Okay, so let's have a look at this main.go that we're working with here. So the first line here is describing the namespace. The package is going to be main, and you do have to have a main package in your Go application. This is the entry point to Go. And then we have our imports here. Imports are very similar to how you would do them in Node, but you're just going to list them out. You can name these imports. So let's say we wanted to rename this Chi package here. We could rename this by Chi router, and then we could refer to this as Chi router here. The next thing that we have is a struct, and this is like a TypeScript interface, but where TypeScript interfaces are removed when you compile your code, structs are a core part of Go. So for example, in TypeScript, this would be interface to do, and then we would define our properties on here like a title string. So we have a title. So the first thing to notice is that title starts with a capital T. This means that this property here is public. So the same as to do here, this means that our to do property is a public property. This means that it can be imported into other packages. Then we have a string, and this is the data type that we're using. You can see down here for done, we have a bool, which is just a Boolean, and there's lots of data types in Go. The second thing that is unique to Go is that we have these template tags here. And this is saying in JSON, I want this field to be called title. So what this allows is for you to have something that is uppercase here or renamed to anything that you want. And then when we export this to JSON, you can change the name here. So we could say this is to do title. And now when we return this in JSON format, the key is going to be to do title. This is a really powerful feature, and this allows you to refactor your code. The next thing that we have is our main function, and this is the entry point to our Go application. So when we run Go run, you're going to be looking for this main function here, and we're going to be executing it. So the first thing that we're doing here is creating a variable, then we're going to assign it a value, and we're going to infer the type of to-do here's from the value. So you can see here, if we remove this colon, we get an error, and we need to say that this is a var, and it's of type to do. But instead, if we use the colon, then we can just infer that type here from to-dos. Okay, so this to-do here is creating an empty object, and that empty object is an array, or in Go, we call this a slice. So this is an empty array of the to-do struct that we have defined up the top here. So we can access this just like any other array, and we can say to-do 0 is equal to, and then we can define it a new value here. We can say title is buy milk. So the next thing that we're doing is we're creating a new instance of our chi router. So this chi comes from this package up here. You can see that VS Code highlights it for me. And then we're executing this new router function. You can see that new router starts with a capital N. If it didn't, then we wouldn't be able to access this property. It's starting with a capital N makes it public. And we can also command click into this function here, and you can see exactly what it does. And there's going to be comments all over the code. The great thing about Go as opposed to TypeScript is when you command click into this, you're seeing the actual function as well as the types. So you can see here that we just return a new instance of mux. We can click into that, and now we can see what this function here is returning. If we have any other functions in here, we can click into that, and we can dive into the actual code here. The next thing we're doing is using some middleware. This is just middleware that comes with GoChi. You can see that it comes from the GoChi middleware package. By the way, GoChi is like a lightweight version of a router. There's more heavyweight versions of routers, such as Fiber or Jin inside of Go, but I really like using these lightweight ones because they don't add too many abstractions over the actual Go's HTTP package. So you can see here we're using HTTP response writer, and this HTTP package is part of the Go standard library. So then the next thing that we're going to do is to define a route. So we're going to say router.get. So this means that we're going to be listening for the get method on this Healthcheck endpoint. Another thing about Go is that we always use double quotes. So you can see here, if I change this to single quotes, Go doesn't like that. It says that this is a syntax error, and this takes a lot of the guesswork out because you just always use double quotes. The next thing that we're going to do is to provide a callback function here. So if you're used to JavaScript or TypeScript, this is going to be very familiar. So the way that you would do this in JavaScript is actually pretty much the same. If you had a router object, you could call .get, and then you could provide a callback function. So inside of this callback function, all we're going to do is to respond with a 200, and we're going to respond with some bytes that just say okay. So we're going to call W, which is our response writer. Then we're going to call write. And you can see here when we hover over this, we're going to get the comment that is above this write function here inside of this helpful box. So we can click into that, and you can see that we get that comment that is above that write function here. So I do recommend when you go through and you're learning Go, just go ahead and read these functions here, and you're going to get really familiar with the standard library. So you can see that the write function here takes a slice of bytes, and inside of our slice of bytes, we're just going to put a string. So why is this a slice of bytes and not a string? Well, a string is a high-level data structure, and a string is essentially just a slice of bytes. So the next thing that we have is a endpoint to create a to-do. So you can see that we're going to listen for the post method on this to-dos endpoint here. And again, we're going to have this same callback function that takes two arguments, our response writer and the actual request. One thing to note is that the request here is using a pointer, and I'll go through why that is in just a second. So we're going to create an instance of a to-do, and you can see here that we're defining this as a var. If we remove the var keyword, then we can just say that this is a to-do, and we need to provide some brackets there as well. Then we're going to create a new instance of a decoder, and JSON is also part of the standard library here. You can see encoding/JSON. Then we're going to decode the body into this to-do here. So what we're doing here is we're creating an empty to-do. Then we're going to create a new instance of a decoder given our body here. And then we're going to put the result of this decode function into the to-do. And so the reason that it's able to do this is because we're using this ampersand symbol here. So this means that we're providing a pointer to a to-do. So we're telling decode here, hey, there's this bit of memory, and when you decode this function, I want you to replace what is in this bit of memory with the result of that function, and that is going to modify our to-do function here. So this is similar to why we're using a pointer for request, and that is because we might want to modify the request object. So with response writer, this is just a set of functions that we can use. We don't want to modify anything on the response writer, but we may want to modify things on the request. So for example, we could modify the request to update the max bytes reader. And so we can pass in the response, the body, and the maximum number of bytes. And the reason that we can do this, modify the request body here, is because we've assigned a pointer to the request. The reason we can do this here, modify the request body, is because we pass in the pointer. If we didn't do this, we would modify the request body inside of this handler, and then when GoChi does the rest of its business, the request body wouldn't be modified anymore because we would create a new instance of our request just for this function here. This lets us scope the request for the actual request object in memory, and it means that we can modify it. So if we go into this new decoder here, so if we go into our decode function here, we can command click into it. You can see that this returns one variable, and this variable that it returns is going to be an error. So you can see here that we're getting our error out of our new decoder. And we're assigning it a type and a value at the same time. So if we don't get an error and everything was successful, then error is going to be nil. So then we need to check to see if error is not nil. And if error is not nil, we're going to write a new header, and this header is going to be status bad request, and then we're just going to return out of this function. So a lot of people don't like Go for this very verbose error handling here. I do personally like it because it means that you are checking errors at every instance of your application. You'll often see a lot of awaits inside of your JavaScript or TypeScript code, and those awaits aren't wrapped in try catch. That means that you're not actually catching those errors. So in Go, as long as you're actually getting the value out, then you need to check that error, because if I remove this block here, you can see that I get a syntax error because I have this error object declared and it's not used. Okay, so the next thing we're going to do is we're going to modify our to-dos object up the top here, and we're going to append to it. Then we need to assign what we're going to append. So this is the to-dos object again. And then we need to give it a value of what it is that we're going to append. And in our case, it's going to be our to-do. Then finally, we're just going to respond with a new status code, and this is going to be HTTP status created. This status created here is actually just an int. So you can see here it's an int with a value of 201. So 201 is the HTTP status for created. So if we command click into that, you can see that we just have a bunch of these constants here with numbers assigned to them. So I could easily just change this to 201 and it's the exact same value. I think this is just a little bit better because it's saying that we're responding with a status created. If you just say 201, you're sort of saying to the person who modifies this code next, hey, I expect that you understand what 201 means, instead of just explicitly saying it with a constant. So our next endpoint is going to be to get to-dos, and by now you should be able to read what it is that this is doing. So again, we have our callback function. We're going to call a function on our response writers. This function is called header, and then that is going to return another function. And that function is called set, and set takes two arguments, both strings. You can see here, it takes a key and a value. So the key is going to be content type, and then it's going to be application JSON. Then we're going to call JSON.newEncoder. So remember up here, we called new decoder. So decoder decodes some JSON into a struct, and now we want to encode a struct into some JSON. And we're also going to pass in our response writer here. So this is going to do the encoding and the responding for us. Then we're just going to catch the error. So if this returns an error, then I want to respond with a header of status internal server error. And this is just a 500 error. And then we're going to return out of the function. Okay, so that's our handlers done. And when we go to build our URL shortener, the handlers are going to be pretty much as simple as that, but we're going to have a little bit more structure because we're going to be writing to a database. Okay, so the next thing that I'm doing is creating an instance of a server. So I'm calling http.server, and http.server is just an struct, and this struct has a bunch of properties that you can assign to it. We're only assigning two properties, the address and the handler. So the address is going to be a string, and this is :8080, and this is the port that we're going to be listening on. So you do need to define the port here. If you omit that, then it's not going to work correctly. For some reason, this address requires that you also include the colon. Then our handler is just going to be an instance of this chmux router. So the next thing we're going to do is to create a channel. Now, I'm not going to go too deep into what channels are because that would be a totally different video, but channels are essentially a way to communicate across Go routines. And Go routines, you can see here, we have a function with the Go keyword in front of it, like creating a async function in your TypeScript code and then not awaiting it. So it moves this off into another lightweight thread. So we can essentially execute this function here, and we can pass this off to another thread, and we're just going to continue our program down the bottom here. Now, a thread in Go is a lightweight thread, so we can spin up a lot of these threads, and they're not going to be very expensive to start up or shut down. They're not one-to-one with operating system threads. If they were, they would be very expensive to start up, shut down, and you would have some hard limits on those. But these are just virtual threads inside of the Go runtime. So Go might use other operating system threads. I'm not sure, and you don't really need to know anything about that. So let's get back to channels. Channels are used to communicate across Go routines. And the reason they can do that is because they are thread safe. And by thread safe, it means that you can write to a channel inside of a Go routine, and then you can read out of that channel in other Go routines or in your main program. Okay, so we're going to assign this a value of sigchan. We're going to assign it a value and infer the type at the same time. We're going to use this make keyword here, and the make keyword is a little bit funny in Go, but we do need it to create channels. Then we're going to tell Go what it is that we're creating, and in this case, it's going to be a channel. Then we're going to assign a value to that channel. So channels can only have one value. So let's say we have an int chan, and we're going to say make channel, and this is going to be a channel of integers. And this means that we can only pass integers into this channel. We couldn't all of a sudden pass our operating system signals into this integer channel. Then the next argument here is the size of the channel. So this has a size of 1. So we could specify this has a size of 1,000, for example, and that means that we can start passing 1,000 items into that channel. But this reason this has a 1 is because down here, we're going to block until we get something on that channel. And so the way that we're going to get something on that channel is we're going to use this signal.notify. So signal, again, comes from the Go standard library. And we're going to use this notify function here. We're going to pass in our channel that we created up the top here. And then we're going to pass in a list of signals that we're going to listen for. So in our case, we're going to listen for a signal interrupt and a signal terminate. When we receive one of those signals, we're going to write it to this channel. And then down below here, we're going to block the execution of our program. So you can see that anything below here until we get something on that channel. That's what this syntax here means. It means block until we get something off that channel that we can read. So essentially what we're doing here is creating graceful shutdowns. The next thing we're going to do is to create an anonymous function. We're going to execute that anonymous function, and we're going to run it inside of a Go routine. So we're not going to block. I can put something here that says fnm.print line, and this just is going to say press Control C to stop the server. Now this is going to print when I run this application, and it's not going to block here. The reason for that is because I have this Go keyword here. So when we run this function, we're going to print a line that says server is running. Then we're going to call that srv.listenandserve. And then we're also going to do some funny stuff here. This is weird syntax that confused me when I first started. So I'm going to show you now. So when you do see this syntax, you're not going to be confused. We're going to say if error, then we're going to assign a value to error from this listen and serve. So listen and serve, you can see here, it's going to return an error. And then we're going to test to see if the error is not nil. And if it isn't, then we're going to run fnd.printf, which is print fatal. So another way to write this would just be to call srv.listen and serve, assign the error value, and then just say if error is not equal to nil, then run this function here. Then run this block of code here, sorry. So that is a different way of writing this. But if you don't need to use another value, you'll often see it written in this weird sort of way where we assign the value and test it all in one block. You obviously can't do this if you need to get another value out. So let's say we got a value of Bob, then you couldn't just use Bob down the bottom here. This wouldn't work. Okay, so once we receive a message on our signal, so we've got a signal interrupt or a signal terminate, we're going to print this line here. Then we're going to create some context, and context in Go is extremely powerful. And I'm not going to get too much into it, but you're going to see context everywhere. Essentially what we're doing here is we're saying, okay, you've now got 5 seconds to completely exit. Otherwise, we're just going to exit with an error. The reason that you might want to do this is because let's say I had a Go program that processed a bunch of jobs. So I'm listening to a queue, and then when I get a message on that queue, I want to write it to S3, for example. I don't want to write a job every time I get something on that queue. I want to hold it in a buffer for a little bit. So I want to hold 100 messages in the buffer, and then I'm going to write them to S3. Now, what happens if our buffer is at 50 messages and we get a kill signal? Well, all of a sudden, I want to flush out that buffer and I want to write them to S3. And in this program, we have 5 seconds to do that. And if we don't do it, we're going to get an error. So that's why you might want to use graceful shutdowns with a timeout. Okay, so we're going to call this with timeout, and this comes from the context package. We're going to give it a context of background. Now, I'm not going to get too much into what this means. And then we're going to give it a time. So this 5 here is going to be timed by time.second. And managing durations and times in Go is actually extremely easy because you can do stuff like this. And this comes from the time package. And this is just going to give you 1,000 times millisecond. And essentially this is 5 seconds. It's exactly what it looks like. Okay, so we're going to get 2 values out of here. We're going to get our context and we're going to get a cancel. So cancel just means discard this context, essentially. We're done. And we're going to use the defer keyword here. So this defer keyword essentially means run this at the end of the program. So this would be equivalent to just moving cancel down the bottom here. And this would be exactly the same. The reason we use defer here is because we can then use the value as soon as we get it. We don't have to move this value down to the bottom of the program and this essentially cover these 8 lines of code. We can just call it straight away, use the defer keyword, and then when somebody reads this line here, they're gonna say, okay, we're gonna get cancel, and then at the end of the function, we're gonna call cancel. You don't have to scroll to the end of the function to see it. So again, we're using this weird error catching and assigning syntax here. So we're going to call shutdown, and this is just going to shut down a server, and then we're going to print a line. So let's run this. So to run this code, I'm going to say go run cmd/main.go. If you didn't have your main program inside of this cmd folder here, you would just call go run main.go, but we do have it inside of cmd. So you can see that I get this press Control C to stop the server. So let's go look at our code again. So you can see that we get this line here before we get this line up here. And the reason for that is because we've just spun this off onto another Go routine and continued the execution of our project. Let's give this a kill signal and see what it does. So you can see I can press Control C and we get this shutting down server, which comes from here. So you can see we blocked at this line here. And then we get a error, HTTP server closed, and then server shut down gracefully. Okay, so let's refactor this a little bit so we can see how we might structure an application. So inside of our root folder, I'm going to create a new folder and I'm going to give this folder a special name. This special name is going to be internal. Now this is a special name because let's say we were publishing a Go package. If we have code inside of internal, it is never accessible outside of the Go package. So you can see here that we're defining our module. It will never be accessible outside of that module. Of course, we're not creating a library here, but creating the internal directory is still a pattern that you'll see across all Go projects. This is where the logic of the application is going to live. Okay, so inside of internal, I'm going to create a new folder and I'm going to call this handlers. And then inside of handlers, I'm going to create a new file for each handler that I want to create. So I'm going to call this one healthcheck.go. Now we can move our Healthcheck handler into this file. So I'm going to give this a package of handlers. And I'm just going to disable Copilot so it's a little bit easier to follow. Now I want to create a struct for this handler. So I'm going to say type Healthcheck handler, and this is going to be a struct. Now our struct is not going to take any arguments. So we're just going to leave this empty for now. But I then want to be able to create a new instance of this handler. So I'm going to say func new Healthcheck handler. And this is going to be a function. Then I'm just going to return Healthcheck handler. And we're not going to pass in any params here. So Go is telling you that there's an error here. And the reason is because we're essentially saying that Healthcheck handler returns void. It doesn't return anything. But down here, we're returning a new instance of a struct. So if we hover over the error, it's telling you exactly what it wants. It has too many return values. What it has is an instance of a Healthcheck handler, but what it really wants is nothing. So we can change this by saying that it should return an instance of a Healthcheck handler. Okay, so now we need a way to handle this router here. And the way that we're going to do this is we're going to create a function on the handler. So I'm going to say func. Then I'm going to give it some brackets here. I'm going to give it a variable called h, and this is going to be a pointer to our Healthcheck handler. And then the function name is going to be serve HTTP. We're not going to take any arguments. And we're also going to return a void. So let's copy, or let's cut the logic out of here. Actually, we are going to take arguments in serve HTTP. The arguments that we're going to take are going to be the response writer and the request. So let's cut that and paste that in. Then I want to copy the logic for writing the bytes, and we can paste that in. Now, when we save, VS Code is going to import our HTTP package for us from the net namespace. Okay, so what are we doing here? We're essentially modifying this struct to add a struct method. And the struct method is going to be called serve HTTP. And this H here is essentially saying this. So let's say we had a property on our Healthcheck handler. So let's say this is name, and this is just going to be a string. When we create our Healthcheck handler, we can say that the name is going to be Tom. Now we could access this property by saying h.name, and this value here would be Tom. So we can remove all of this. Now the way that we use this function now is we're going to remove the callback and we're going to replace this with a handlers. So we're accessing the package namespace, which is handlers here. Dot new Healthcheck handler. So we're going to execute that function. And this function is going to return an instance of this struct. And this instance of the struct has a method called serve HTTP. So we can call dot serve HTTP. Okay, so we have an error here. Let's hover over this. Cannot call pointer method serve HTTP on handlers.healthcheck. The reason for this is because we're not actually returning a pointer for the Healthcheck handler. So let's go into that and we can fix this. So we need to define the return type as a pointer to the Healthcheck handler. And then we need to say this is a pointer to the Healthcheck handler. Now, a pointer is essentially just a block of memory. It's not the actual value. So if we logged out the value of this health check handler, we're just going to get a hexadecimal number, and that is where that value is stored in memory. There's a few reasons you want to use pointers in Go. One is because you want to be able to modify the actual value. The second is that if you have a large object and you pass around a pointer instead of the actual value, you're going to save a lot of memory, because a pointer is just a small hexadecimal number, whereas an object can be infinite number of bytes. And then the third reason is because you might want to be able to return nil. So you can see here that instead of returning our health check handler, we can actually just return nil. But if we weren't using a pointer here, we wouldn't be able to return nil. So you're going to see this later on when we have our store, and you might want to find a to-do by an ID. If you return a pointer, you will be able to return nil. So if that to-do doesn't actually exist, you can just return nil. But if we weren't returning a pointer, then you wouldn't be able to return nil. You would have to return some value, which just doesn't make any sense. Okay, so this is our health check handler converted. Let's go convert our create to do handler. So I'm going to create a new file inside of our handlers called create to do.go. Now, this package structure here that I'm creating is the package structure that I like to create, but you might like something different. The one thing that I do advise is to just follow this structure. And then as you learn more, you're going to be able to come up with different ways that you like to structure the package that make sense to you. But you're not really going to know that until you understand how the application works and how it runs and the nuances of Go. Okay, so we're going to do the same thing as we did for our health check handler. So I'm going to say type create to do handler. And this is going to be an empty struct. So you need to provide the struct keyword here because you could also create an interface, and we'll get into what interfaces are later. And these are especially useful if you're going to be writing tests for your application, because then you can pass in a interface for something, and then you can create your own version of that interface or something that satisfies that interface. So we're going to be creating mocks, for example, that satisfy interfaces. Okay, so now we're going to have a function, and this function is going to be new create to do handler. So I'm just going to copy paste that. And then we're going to return a pointer to our create to do handler. Now we need to tell Go that we expect a create to do handler, and that is of course a pointer. Now we want to get some params in here, and there's a few different ways that you can do params. One, you can create a struct, or you can just start passing them in. So the params that we need is going to be our to-dos, and we need to pass this in so we can write to it. And this is going to be an instance of a to-do, but I don't want to get that from main. Importing from main is a little bit weird. You might be able to do it. I'm actually not actually sure because I've never done it, and I don't advise you do that. So I'm going to create a new folder inside of internal, and I'm going to call this store. And inside of store, I'm going to create a new file. I'm going to call this store.go. And this is going to be package store. Now this is going to be all the data types that we do store. So I'm going to cut that out. I'm going to paste that into store. Now I'm going to say that our to do here is a store.todo. And you can see that VS Code imported this from internal/store for us. So our main file here is going to be complaining. So let's say store dot, we can save that, and VS Code is going to import it for us. Or not in this case. Let's just copy that, and we can paste that in. And we need to do that for everything. So every time we reference a to-do, we need to provide the namespace where that to-do comes from, where the to-do struct comes from, sorry. Okay, so now when we create our to-do, we actually want this to be a pointer to a to-do. And in our create to-do handlers, we can have a to-do, and this is going to be a pointer to store.todo. And we need to use the asterisk. And VS Code is giving us warning here because to do is unused. That's fine. We're going to be using it later. So now we need to assign a value to this to do. So I'm going to say to do is going to be our to do. So this to do here comes from the arguments passed in, and this is the key that we're going to be using. And the other way that we could do these arguments is create a struct. And this is good if you have lots of arguments. This is essentially in TypeScript having a function called create, and we're going to have a to do. Then we're going to have another property called name. Then we're going to have another property called done. So that's essentially what we're doing here. What we really want is to wrap this in an object and take a single argument, and then we're going to call this params. So let's say we had params here, then we could say params dot name, params dot to do, for example. So the way that we're going to do that is we're going to say type create to do struct. So create to do params is going to be a struct. Then we're going to have our to do. And this is uppercase. This needs to be uppercase because otherwise we're not going to be able to access it across the different modules. This to do here is lowercase because we're only going to use this in our serve HTTP function. Okay, so we need to define a value to this, a type, sorry. So this is going to be our store dot to do. Now we can say that we get our params down here, and this is going to be create to do params, and this should be create to do handler params. Now to access this, we simply do params dot to do. Okay, so now let's create our serve HTTP function. So I'm going to say func. I'm going to create a variable called h, and this is going to be our pointer to create to do handler. This function is going to be called serve HTTP. Serve HTTP is going to take our response writer, so it's going to be http.response writer. Then we're going to take our request, which is going to be a pointer to http.request. And we can cut all of the body out of this function here. We can paste it into our serve.todo. Let's save this. And you can see that the JSON package was imported for us. I've actually made a little bit of a mistake here. So this to do should actually be to do's. So let's change that. So this is our slice of to do's. And this actually needs to be a slice. This needs to be a slice as well. Okay, so now we can pass that in. And to access this, we can say h.todos. And we're going to append to h.todos. So Go is complaining here, and you can see the first argument to append must be a slice, but we have to-dos variable, which is a pointer to a slice of to-dos. We can fix this by saying we actually want to use the value here. Okay, so let's go update this function here. So this is going to be handlers.new create to do handler. We're going to execute that. Then we're going to call .serve HTTP. This is handlers, not handler. So we do require some arguments here. So this is going to be handlers.create to do params. Now we're going to pass in our to-dos, and this is going to be our to-dos here. Okay, so the final handler here to refactor is going to be our get to-dos. So let's create a new file called get to do.go. So have a go at refactoring this yourself. So the first thing we need to do is we need to create package handlers. Then we need to create a struct. So I'm going to say type get to do's handler. And this is going to be a struct. We're not going to have any arguments in here. Actually, we're going to have our to-dos. So give handlers a capital H. Then we're going to have our to-dos, which is going to be a pointer to a slice of store.todo. Then we're going to have our new get to do handler function. So I'm going to say func new get to do's handler. It's going to be a function, and we're simply going to return get to do's handler. Now we also want some params in here. So I'm going to say type get to do's handler params. and that's going to be a struct. We're going to have our to-dos, which is going to be a pointer to a slice of store.todo. We're going to return from here a pointer to a get-to-do handler. We're going to accept some params. Those params are going to be get-to-do handler params. Then inside of our get-to-do handler, which actually needs to be a pointer, we're going to say to-dos is going to be our params.todos. Now let's go use this function, or let's actually create our serve HTTP function. So I'm going to say func h. By the way, I use this one letter variable name h here, which just stands for handler. You can call this handler or something, whatever you like. But I don't feel the need to do that. The reason for that is because we have the type right next to it. So this function is going to be called serve HTTP. We're going to copy our response writer and our request, paste that in. Now let's just cut the body of this function, paste it in, and we're going to encode into our handler.todos. Okay, now we can use this function. So we can use this struct. So I'm going to say handlers.new get todos handler. We're going to pass in some params. So this comes from handlers, get to do params. The reason that you have to do this is because anytime you are going to pass something in, you need to tell Go what the type of that thing is. So this is going to be to-dos, and this is going to be our to-dos. And then we need to call .serve HTTP. So this syntax here in TypeScript would be something like, let's say we had a, let me create a new file. So let's say we had an interface of params, and this interface had a name, which is a string. So this syntax here, where we say handler.getToDoParams, would be something like const params, and then we assign it this interface of params equals, and then we assign it a value here, and we can say name is going to be Tom. So that would be the equivalent of using this param struct here. Okay, so this is all looking good now. Let's go test out this application. So I'm going to run this again with go run cmd/main.go. I have this Thunder client inside of my VS Code instance, so I can open this, and this is going to allow me to send HTTP requests. So let's try get our to-dos, and you can see that we get an empty slice here. Let's create one with a title of hello. And you can see that we just get our status of 201 created. Let's try get this back, and you can see that we now get our slice of to-dos back. So this really highlights why pointers are important, because what we're doing is we're creating a slice of to-dos up here, and then we're modifying that to-do in a completely different package. And then we're going to get that to-do again in a different package. And this main file here is orchestrating all of that. It's storing our slice of to-dos here. So we're finished refactoring this application. Let's go ahead and start a new Go application from scratch. So now that you know the basics of the Go syntax and how to structure your project, we can start creating a project from scratch. And we're going to create a URL shortener. You don't need anything to follow along with this URL shortener. We're just going to use an in-memory database. So I'm here in a new directory, and the first thing that I'm going to run is go mod init. And now we're going to give our module a name. So we can call this github.com/TomDoesTech, and I'm going to say /URL shortener. Now in TypeScript, the equivalent to this would be running something like npm init, which is going to create a package JSON for you. In our case, it's going to create a Go mod file, and we're going to have two lines in here. One is this line that declares our module, And then the second is the version of Go that we recommend running this module with. Okay, so the next thing that we can do is make a directory, and this directory could be called CMD. Inside of the CMD directory, we can create a new file, and this new file, of course, is going to be our main.go. So we need to declare the package, and the package is going to be main. And then, of course, we need to declare our main function. So I'm going to say func main. And then here for now, I'm just going to fmt.print a line. And then this line is going to be hello world. So let's go back to our terminal, and we can run go run cmd/main.go, and we should see hello world get printed out here. Okay, so the next thing that I want to do is I want to install Qi so we can use this as a router. And to install Qi, we can say go get github.com/go Qi/version5. Now, you'll often see a -u in here as well, and this is just to update your local cache. You don't have to do this, especially if you're new to Go. You're not going to have this in your local cache. So let's run this. So you can see that it downloaded GoQi, and if we have a look at our mod file here, you can see that we're now requiring GoQi. And if we have a look at the sum file, you can see that we also have these two lines referencing GoQi. So inside of our main function here, let's just cut out this line. And let's say we're going to use the colon equals, and then we're going to say qi.new router, and then we're going to execute that. Remember, this symbol here is going to assign the value and infer the type. Then the next thing that we want to do is to create an instance of a logger. So we're going to use a proper logger in this application. And luckily, Go version 20.1, I think it is, has a structured logger built in called slog. So we can say logger = slog.new. If VS Code is telling you that slog doesn't actually exist from log/slog, make sure that you are using a newer version of Go. So you can see here that I'm using 1.21.3, which is a very new version of Go as I'm recording this video. So let's execute the new function here. And in here, we can put in a new JSON handler. So I can say slog.new JSON handler. And then we're going to give it an output. So I'm going to say os.stdout, and then we're going to give it nil. So we can look at what these arguments are here. If we hover over the JSON logger, you can see that we need to give it a writer, and the os.stdout is going to use the IO writer interface, which is why we can use that in the first argument here. And then we need to give it some options. You can see that this is a pointer to this handler options, and that's why we can give it nil. You could also copy this, and then you could put some brackets there and say this is a pointer. And that would do the same thing, but we can just use nil because that is a pointer. And what I mean by the first argument here being a interface is if we click into this, you can see that we have W and this is io.writer. If we click on writer here, you can see that writer is an interface. It's not a struct, which means that we can put anything in there that satisfies this interface. If this took a struct, that would mean that we have to put that exact struct as the first argument into the new JSON handler here. But interfaces, as we'll see later on, make it really easy for you to inject whatever you want into these functions. Okay, so the next thing we want to do is to create an instance of context. And this instance of context is going to be our overall instance of context. All other instances of context are going to use this one as their base context. So let's call this server context, and we're going to server stop context, and this is just going to be the cancel function. So this is going to be context dot context, and then in the first argument here, we're going to give this. So this is going to be context dot with cancel, And then in the first argument, we're going to give this context.background. Now we're not going to give this any timeouts or anything like that. This is just our parent context. We can create a context that has timeouts from this context. Okay, so let's make our channel for the kill signal. So I'm going to call this kill sig. And we're going to use the make keyword here. And then we're going to give this a channel, and our channel type is going to be os.signal. And then our channel size is going to be 1. Okay, so when we get a kill signal, let's pass that into this channel. So let's say signal.notify. We're going to pass in our kill signal channel, and we're going to pass in the signals that we want to listen to. So I'm going to call syscall.sig int and syscall.sig term, so signal terminate. And then we can also pass in sig quit. So sig quit. Okay, so when we press Command C or Control C, we're going to pass in a signal terminate, and then that's going to go onto our kill signal channel. So the next thing I want to do is to create an instance of my server. So I'm going to say srv or svr, and this is going to be a pointer to http.server. And remember, HTTP server is just a struct, and we can pass in some properties here. So we want to use address and handler. So the address is going to be a string. And remember, we need to pass in the colon and 8080. And then the handler is going to be R. And R is our GoChi router. So let's handle the graceful shutdown a little bit different to how we handled it before. So we can do this inside of a Go routine, and our Go routine is going to execute an anonymous function. So we can create an anonymous function by just using the func keyword with our brackets here, and then we need to have the curly braces here, and then we can just execute our anonymous function. In JavaScript, this would be the same as an IFI. So if we scoped it in these brackets, and we said function, have our function like that, and then we execute that function. So this would be the IFI in JavaScript, the immediately invoked function, whatever IFI stands for. But of course, we want this to be a Go routine, and so we can simply put the Go keyword in front of func here. Okay, so we want to do the same sort of thing as we did before. We want to block in this function here until we receive something on this channel. So we can do that by using the arrow and then our kill signal. So now we're going to block in this function, and this part down here is not going to run until we receive something on that channel. And what are we going to receive on that channel? Well, we're going to receive a kill signal. And if we want to use that kill signal, we can simply just say sig is equal, and then we're going to get the value of whatever is in this kill signal. So if we hover over this, you can see that it is an os.signal. And this is possible because remember I said before that channels are thread safe. You can pass data into a channel in a different Go routine, and you can use it in other places. So we could in fact create a Go routine here, and we could use this notify inside of this function here. And these are two different threads now that can communicate with each other via a channel. But there's no reason for us to do that. So I'm just going to remove that code there. Okay, so let's use our new logger. So I'm going to say logger.info, and I'm going to say got kill signal shutting down. So from now on in this function, we're going to start the shutdown process. So we can pass some arguments into this logger here, because remember, this is a structured logger. And I can say slog.string. And my string is going to be my signal. And I need to cast this to a string because, of course, I'm saying that it's a string here. And the first argument is just going to be whatever we call this string. So this is going to be our signal. Okay, so I want to create some new context, and this context is going to have a timeout, and we're going to use that timeout to say, hey, Go, you've got 5 seconds, for example, to shut down. Otherwise, we're just going to exit with an error. So I'm going to call this shutdown context, and we're going to have cancel, and this is going to be context dot with timeout, and we're going to put our server context in here. And I'm going to say this is 5 times time dot seconds. So if you need more time to shut down, then you can change this number here to whatever time that you want to give your server to shut down. Okay, so how do we exit this with an error if our shutdown context time limit is exceeded? So we're going to do this in another Go routine. So I'm going to say go func, and then we're going to execute this immediately. So we're going to block here until we receive a signal on done, and we're going to see if we have an error on our shutdown context. So I'm going to say if shutdown context dot error is equal to context dot deadline exceeded, then we're going to say log dot fatal shutdown deadline exceeded. So let's have a look at log.fatal and what that is. So log.fatal is equivalent to print followed by a call to os.exit, and we're going to exit with a 1, which means we're exiting with an error. Okay, so now let's try shut down the server. So I'm going to get an error out of this, and this is going to be svr.shutdown. And we're going to pass in some context here, and this is going to be our shutdown context. And if we do get an error, so if error is not equal to nil, then we're going to call log.fatal, and we're just going to pass in our error. So now we need to cancel our server context. So we have this server context cancel function here. So if we go into that, you can see that it is just cancel. I've renamed it to server stop context. And so we can execute that. And we can say logger.info server shutting down. Now we can call cancel on this context here. So we're canceling our shutdown context, and that's it. Okay, so before we start listening to any endpoints, I just want to start the server up. So I want to do this in another Go routine. So I'm going to say go func. And of course, we want to execute that. And I'll say error is equal to svr dot listen and serve. And then if we do get an error, so if error is not equal to nil, then we're just going to log.fatal again, .fatal. And we're going to pass in the error. And then I just want to log a line saying that we're ready to do some work. So logger.info, and we can say ready to work. Now you may have picked up on something here, and if you have, congratulations. If we run this code here, it's just going to exit because we're just running these Go routines, and these Go routines are going to go off into the other thread. Go's going to get to the end of the line here and say, oh, my work is done. Let's just exit the program here. That's not what we want, of course. And so one way that you could fix this is to not listen and serve inside of a Go routine. Another way that you could do this is to just block until we receive something on our server context here. And remember, the way that we block is with this weird syntax. So this is going to be server context.done. And until we receive something on this server context.done, we're just going to block our Go program from exiting. And the way that we're going to receive something on this context here is if we cancel it inside of our graceful shutdown function here. So hopefully now you can start to understand why this context package is so important. Okay, so now let's start up our terminal, and we can say go run cmd/main.go. And Go is complaining here. It's saying that we haven't installed Go Chi, and you can do that by saying go get GoChi. Of course, we have installed GoChi, so there may be an issue with the import, and sometimes Go does this. And you can see here that is importing the wrong package. We want /v5. That's what we installed. Now let's start this up again. And you can see that we have ready for work. And we can press Control C, and you can see that we get server shutting down and our server exited. Let's try exceed the deadline. And we can do that by calling time.sleep. And then we can sleep for a number of seconds. So we can sleep for 10 times time.second. So let's start this up again. We can press Control C. So we're sleeping for 10 seconds now. And we got shutdown deadline exceeded, and we exited with a status code of 1. So we can see that this deadline exceeded function here is working. So our first handler to make is always going to be our Healthcheck handler. So let's go ahead and do that. So inside of our root directory, let's create a new folder, and I'm going to call this internal. Inside of internal, I'm going to create a new folder called handlers. Inside of handlers, I'm going to create a new file called healthcheck.go. And you've seen all this before. So if you feel confident enough, try pause the video and fill in this Healthcheck handler on your own, and then come back and see if you got it correctly. So the first thing that we want to do is to declare our package. Our package is going to be the handlers package. The next thing we want to do is to declare our struct. So I'm going to say type Healthcheck handler is going to be a struct with no arguments. The next thing we need to do is to have a function that returns a new Healthcheck handler. And I say function new Healthcheck handler. And this is going to return a pointer to a Healthcheck handler. And we're just going to return Healthcheck handler with some brackets here. The next function that we want is our serve HTTP function. So I'm going to say function. And remember, this is going to be a method on the struct. So it's going to have a H variable that is a pointer to Healthcheck handler. Then the function is going to be called serve HTTP. We're going to have W, which is going to be our HTTP.response writer. Then we're going to have R, which is going to be a pointer to HTTP.request. Then we're going to W.write, and we're just going to write a slice of bytes. And that slice of bytes is just going to have a string that says OK. And this is not a pointer to new Healthcheck handler. That doesn't make any sense. It's a pointer to our Healthcheck handler struct. And of course, because it's a pointer, we need to use a pointer here. Okay, so let's go back to our main.go. And we can define our route here. So I'm going to say r.get, and we're going to listen to /healthcheck, and then we're going to give a handler of a new handlers.new Healthcheck handler. We're going to execute that function, and then we're going to say .serve HTTP. And this is handlers. And Go is complaining here. And the reason is because we don't want to execute this function here. We just want to pass it in to the handler. Okay, so let's run this. And I can curl http/localhost 8080 healthcheck, and we get back an OK here. Okay, so the next thing I want to do is to create a store for our short URLs. So I'm going to come into our main directory here. I'm going to create a new folder. This is going to be called store. Inside of store, I want to create a new file, and this is going to be store.go. And the package for this is going to be store. So take note of the file structure here. It's really important, and it's something that really confused me at the start. So we're going to have this package store. And this is just like saying this is a generic store of data. You can pass in any implementation that you like. In our case, we're just going to have a DB store, and this is in place of a actual DB store. So you could pass in Mongo, or you could use Postgres or SQLite, whatever you want. And the reason that we do this is because then we can create a mock of that store, and it makes testing really easy. So I'm going to show you that now. So let's create our implementation of a store, and that is going to be a DB store. So let's create DB store, and then inside of DB store, we're going to have short url.go. And let's make this a lowercase u. And this is going to be part of the DB store package. But now we can make a mock of our store. So inside of the store directory here, we can create a new folder, and this is called mock. And then inside of mock, we can create a new file, and this is going to be mock.go. And all mocks are part of the mock package. So let's say package mock. And now we can create a mock version of our store. So let's say type store, and this is going to be a struct. Now in here, we want to put mock.mock. And we don't have this installed. We need to install something called go testify to get this to work. So let's install that now. So I'm going to say go get -u, and this is going to be github.com/stretcher/testify. Okay, so now when we save this, we should import the mock from testify. And we actually don't need this store mock here. This needs to be mock short URL store. So you may be wondering why we're just putting this mock.mock inside of the struct. It looks kind of weird. Usually would have a property here and we would name it mock. But what we're doing here is we're embedding this mock.mock inside of this struct, so then we can use the methods on mock.mock. It's kind of like we're extending this mock struct inside of our mock short URL store. So we're going to see later on when we write some unit tests that you can actually use functions from this mock struct inside of your tests. Okay, so now we have our generic store where we can define our structs and our interfaces. We have our mock, and we have our actual implementation. So let's fill in our implementation, and then we can go fill in our interfaces and our mocks. So the first thing I want to do is I want to create a type. So I want to create a struct, sorry. So this is going to be short URL store. And this is going to be a struct. And let's go back to our mock. This is what we're mocking here. We're going to be mocking this struct here. So we're going to use an interface. We're not going to pass this store in directly into our functions. We're going to say that it requires an interface. Now, both this and our mock here are going to satisfy that interface. And inside of this struct, we're going to have a slice of an object or a struct that is our short URL. So we can say short URLs. And you'll notice in Go as well, when we have initialisms or acronyms, it's always uppercase. So let's say I wanted to say short URL ID, you'll notice the ID is always uppercase. If you do this here, your static check and stuff is going to fail on you. Okay, so this needs to be a slice of store.short URL. And of course, we don't have a short URL inside of our store package. So let's go define that. This is going to be type short URL, and it's going to be a struct. Now we can define some properties that are going to exist on this short URL. So I'm just going to define an ID. Again, notice that this is all uppercase. This is just going to be an integer. So we're just going to auto increment these IDs. And I want to provide some JSON tags. So this is going to be just ID. I could call this whatever I want. I could call this gobbledygook. And when we return this in JSON format, it's now going to be gobbledygook. And then the next thing I want is a destination. So this is where we should redirect to. And this is just going to be a string. And my JSON tags is just going to be destination. The next thing I want to have is a slug. And again, this is going to be a string, and we're going to have some JSON tags here, and this is going to be slug. You can use these JSON tags for a ton of stuff. You can use them for validation, and you can use them for different types. So let's say that we also wanted to store this in a Mongo database. We could define some BSON tags here, and I want to store this as, say, short URL ID. And then in BSON, I want to store this as dest. And then our slug, for example, in BSON, by the way, BSON is just binary JSON. It's just how Mongo stores data. I want to store this as my slug. So now when we serve this out as JSON, we're going to have this as ID, but when we store it in the database, it's going to be stored in a field called short URL ID. This is super helpful. So let's say, for example, I all of a sudden needed to change the JSON that we're serving out. Let's say that we had a spelling mistake here. Well, it's fine. You can just come along, fix that, and you don't have to do anything else to your struct. You don't have to do anything to your Go code or anything like that. It's all just going to be handled for you. It's actually really amazing. And I don't think TypeScript really has anything like that, because in TypeScript, you just work with JSON. Okay, so now we can come back to our short URL DB store, and we can save this, and this is going to import from our store now. Okay, so now we need a function to create a new instance of a store. So I'm going to say func new short URL store. We're going to return a pointer to the short URL store. And then we're going to return an instance of the short URL store. So we require some short URLs in here. So we could pass these in as params. So let's say we had multiple stores and we wanted them to all share the short URLs. You could pass it in as params and you would pass it in as a pointer, but I just want to declare it here. So I'm going to say short URLs is equal to an instance of store. So it's going to be a slice of store.short URL. Now we can say short URLs is going to be our short URLs. One other thing that I should mention is, let's say that we wanted to use a logger in here. Now we could just rewrite this line inside of the package, or we could create a new package and we could just import this logger. We could make it public by creating a capital L logger, and then we could import it into our store function here. But one way that I do recommend doing this, in fact, let's just do it. So let's say type new short URL store params. What I'm doing here is called dependency injection. We're injecting the dependency into the struct instead of just importing it or declaring a new one. The reason that we're going to do this is because we can mock this out, or we can pass a different logger when we go to test. So the logger that I might want to pass is a logger with no output. We don't actually ever log it. Or I can pass a logger with a spy. So I can say that I expect this logger to have been called with X params. And I would do that by creating a mock instance of the logger. Okay, so let's say logger, and this is going to be an instance of slog.log. Sorry, slog.logger. Now let's give this a logger. And again, this is going to be a pointer to slog.logger. So we're just declaring the types here. And now we can get our params. And this is going to be new short URL params. And then when we return our struct, we can say logger is going to be our params.logger. One thing that is also worth noting is that when you call this function here, if you just don't pass in the logger as params, Go is going to be perfectly fine with that. The issue is you're then going to use the logger in here, but the logger won't exist. And you're going to get this crazy error that says it's referring to a nil pointer. And I'll do it just to show you what it's going to do. But when you see that, don't panic. The error looks crazy, but it's usually because you haven't passed in a param here. So this is one thing that I find kind of annoying about Go, is you can't say that this param here is required and have the compiler tell you if you haven't passed it in. So you need to be extra careful, but just write some unit tests for your code, make sure you do some manual testing, and you're going to be perfectly fine. Okay, so let's create a new method on this short URL store. So this method here is going to be to create a short URL. So let's say func, and we're going to have s, which is going to be a pointer to our short URL store. And I'm going to call this create short URL. And I want to have some params here. So do I define the params here, or do I define them in the store? The answer is define them in the store. And the reason for that is because I want to use these params inside of this DB store, but I also want to use the exact same params inside of our mock. And so we're going to define them in our store, which is like our generic version of this store. The mock is another version of the store. It just performs different tasks under the hood. Okay, so let's come back to our store and I can say type create short URL params. This is going to be a struct. Now in here, I just want to define our destination, which is going to be a string. And I want to define our slug, which is going to be a string. If you find yourself in a situation where you're trying to create a short URL and you pass in the params, and let's say this slug is missing, the most likely reason for that is because you would have slug with a lowercase s. You do need to have it with an uppercase s here. Okay, so our params are going to be store.createShortURL params. Okay, so now let's create an instance of a short URL. So I'm going to say short URL is going to be equal to store.shortURL. Our destination is going to be our params.destination. Our slug is going to be our params.slug. And then our ID is going to be our short URLs, s.short URLs. And then we want to get the length of this. So we can use a little function called len. And if you pass a slice into len, then it's going to return the length of that slice. Okay, so now we want to update the short URLs here with our new short URL. So we can say s.short URLs is going to be equal to append short URLs, and then we can pass in our new short URL here. And Go's complaining here, and I find this a little bit funny. So it's saying that we are not defining a new variable here. So all it wants us to do is remove the colon because we don't want to infer the type and assign a new value when we're not actually defining a new variable because s.shortURLs already has a type. We don't need to infer it again. Okay, so now we can use our logger. So s.logger.info, and we can say short URL created. And we can just pass in all of the values here. So I can say slog.any, and then I can say values, and then I can just pass in our short URL here, and it's just going to print out this whole object. Okay, so finally, let's just return our short URL, and Go is complaining because we haven't told it that this function returns anything. So we're just going to say that it returns an instance of a store.short URL. If you were using a database, of course, when you're trying to insert something, it can throw an error. So you would return here an error and your store.short URL. And you can see here now that Go's complaining because we don't have enough return values. So I can just return nil from here, but make sure you're always returning the error from the database. You don't want to just gobble it up. Okay, so while we're in here, let's create our other method. And this is to get a short URL by a slug. So let's say func, and this is going to be another method on the struct, so s.short URL store, get short URL by slug. And we don't need to define some params here. We can just say that our slug is going to be a string. This is only ever going to take one method. So now let's return a pointer to store.short URL and our error. The reason I'm returning a pointer here is because we may not find the short URL, and if we don't find it, we want to be able to return nil. Okay, so this is one thing that people may find annoying with Go. I don't mind it. There's no functions like in JavaScript where you might have a array.find or array.filter, you basically just have to use a for loop for everything. So I want to use a for loop to search through the short URLs and then return the result if we find it. Otherwise, at the bottom of the function, we're just going to return an error. So let's handle that case now. So I'm going to return nil, and I want to return a custom error. So let's come back to store. And inside of store, I can say var error short URL not found is equal to errors.new short URL not found. Creating this custom errors is super helpful. So you can say, is this error an instance of this other error? It's really nice. Instead of just returning the errors.new all the time, you create the error as a variable and then just pass that around. And then you can say, is it an instance of this error? Okay, so now we can use this. We can say store.error short URL not found. Okay, so let's try find this. So I'm going to say for, and then I want to have a variable, and then I want to say short URL is going to be equal to range of s.short URLs. Okay, so this variable here is an int. This is going to be our index. So this is going to start at 0 and it's going to increment from there. And then this is going to be our variable. So in TypeScript, this would be like saying for const short URL of short URLs. And then you could just console.log here, for example, your short URL. So you're essentially defining a variable on every iteration of the loop. And you can see that that's exactly what we're doing here because we're using this equal to and assigning the value. So you can see that we have a value here of short URL from store. Okay, so let's say if short URL.slug is equal to the slug passed in, then we're going to say results is equal to short URL, and then we're going to return our result, and we're going to return nil as the error. So return here references the outer function here. We're returning from the outer function. And if we do reach this call here, it means that we'll never return there. So you can't return multiple times from a function, of course. Okay, so there's the two methods on the store. Let's go to our store here and we can define an interface now that we can pass around. So I want to say type short URL store, and this is going to be an interface. And now we have several methods on here. I'm going to show you an easy way to get those methods. So come into the short URL and hover over it, and you can see it gives you the signature here. Let's go into our store and we can just paste in the signature. Of course, we don't need to reference store here because we're inside of that package. Let's save that, and then let's do that with the other method. So an interface doesn't ever have the implementation, it only ever has the methods on the struct. So for example, you can see that we have our short URLs and our logger. The interface doesn't care about any of that. It just needs to know what methods we have on that struct, because you can initialize a new struct that satisfies this interface with different parameters. For example, we're not defining our mock short URL store here with a logger or a slice of short URLs, but we're still going to make it satisfy the interface. And what I mean by satisfy the interface is that it implements the same methods with the same signatures as the interface does. So Go only has implicit implementations. You can't say explicitly this struct implements this interface like you can in languages like Java, for example. In TypeScript, the way that you might do it is you might say interface animal And then you would say interface dog extends animal. But in Go, all of this is automatic. All you need to do is satisfy these methods here. So you may be wondering, oh, what happens if I forget to satisfy the interface? We're going to know straight away when we go to use that struct, when we pass it into something that requires something that satisfies this interface, Go is going to complain. You're going to know straight away. It's not really a problem. So for example, right now, if we were to try pass in this mock short URL store, Go is going to complain because it doesn't satisfy that interface. So let's update it to satisfy that interface. So I'm going to say func, and this is going to be a method on the mock short URL store. So this is going to be a pointer to mock short URL store. Now we need to have create short URL, and this is going to take params, and this is going to be store.create short URL params. And it needs to return the same thing. So it needs to return, I'm just going to copy and paste this actually. It needs to return the store.short URL and an error. Okay, so now this satisfies it, except for the fact that it doesn't actually return anything. So the way that we can do this is we can get the args that it was called with. And the reason we want to get the args is because we want to say something like, I expect this mock to have been called with these arguments. And we want to make assertions based on that. So m.called, and I want to say params. Okay, so now I've got the arguments that it was called with. I can return args.get 0. And then I need to cast this to a pointer to store.short URL. In fact, this is not a pointer because we're not using a pointer up here. And then I want args.errors, and I want to get errors 1. Okay, so you're going to see later on, we can say mock.on, and then we call this method, and we say, well, when it's called, return these things in the places of the short URL and the error. So we can mock what happens if this function returns an error or if it returns some other value. Okay, let's do the same thing for get short URL by slug. So I'm going to say func m, it's a pointer to mock short URL store, get short URL by slug. We're going to have our slug here, which is a string. And we're also going to return a pointer to store.short URL, or we're going to return an error. Args, and then we're going to call m.called. And we're going to pass in our slug. Then we're going to return our args.get. We're going to get the 0th value. And we're going to cast that to a pointer of store.short URL. Then we're going to get args, errors, and errors is going to be in the 1 place. Okay, so now our mock store satisfies the interface and our actual store satisfies the interface. So the next thing to do is to create a handler for creating a short URL. So inside of our handlers folder here, let's create a new file, and this is going to be called create short URL.go. And again, you should be able to implement most of this function now. So let's say package handlers, say type create short URL handler. That's going to be a struct. And this is going to have an instance of our short URL store. So let's say short URL store, and this is going to be store.short URL store. Now let's have a look at this. This is our interface here. So make sure you do have the interface as the value here. One thing that we could do is we could say dbstore.short URL store. And this is, of course, now going to be our struct. You don't want to pass that in because that means that you have to pass this exact struct in, and you're never going to be able to pass in your mock store. So this needs to be store.short URL store. meaning it needs to be our interface. Okay, so let's create some params. So let's say type create short URL handler params. This is going to be a struct. And this is going to have our short URL store. So this needs to be capital S, short URL store, which is going to be a type of store.short URL store. Now we can have our function that returns our store here. So let's say func new short URL store. It's going to have our params, new short URL store params, and it's going to return an instance of create short URL handler. Okay, so let's say short URL store is going to be params.short URL store. So the next thing to do is to create our serve HTTP function. So I'm going to say func, then we're going to have our handler variable, which is going to be a pointer to create URL shortener handler. And then this is going to be called serve HTTP. Serve HTTP is of course going to take our response writer and our request. So response writer is going to be wt.response writer, and then our request is going to be R and a pointer to http.request. Okay, so we want to get some data out of the body here. The data that we want to get is our destination. So we can create a struct inside of the handler here, and it's only going to be scoped to that handler, or we can create it out the side here and it will be scoped to the whole handler's package. We don't really need it scoped to the whole handler's package, so we can just make it inside of this function. So I'm going to say var request data is equal to a struct, and I'm going to spell request correctly. So when we define the struct here, we're just defining the type. So we're not actually defining any data yet. So this is going to be destination, and then it's going to be a string. And we also want to provide some JSON tags as well, because we're not going to have the user input it as destination with a capital D. We're going to have them input it with destination with a lowercase d. So this is going to be JSON, and then we're just going to have destination. And then Go is complaining because we need to put some new brackets here. So you could define the destination here. So we could say this is going to be google.com. But the issue with that is that we need to decode this from the actual body. And so we have this variable here and we can decode it into that variable. So I'm going to say error. So we're going to get an error out of json.new decoder. And we want to decode the request body. So this is r.body. And then I want to call .decode. And I want to decode this into a pointer to our request data. The reason we pass in a pointer is because if we didn't, we would just be modifying it inside this decode function and would never actually modify this variable here. So now we have an error here. We need to test to make sure that error is nil. So say error is not equal to nil. Then I just want to call w.response.writeHeader. And I want to say http.status bad request. And again, this status is just a integer and it's a 400 integer. Okay, so now I need to define my slug. So I'm just going to make this a hard-coded string for now. And then we're going to write a function to generate a new slug for us. You can use anything to generate a slug. You could use UUID or you could use NanoID. It's really up to you. Okay, so now we can create our params for creating a short URL. So I can say short URL is equal to store.create short URL params. Now we need to put in our destination, and this is going to be our request data dot destination. And we also need to provide our slug, which is of course going to be our slug here. Okay, now we can say created short URL. And I think we get an error as well. So let's say error is equal to h.short short URL store dot create short URL. Now we can pass in our short URL params. So there's two ways you could do this. One, you could define this as a variable at the top here, or you could just take this whole thing and pass it in there like that. In fact, let's just do that because we're not going to use that variable. So we may as well just pass it straight in. Okay, now we need to test for the error. So if error is not equal to nil, then we can just do the same thing again. And let's also return. And we can actually make this a status internal server error. And we need to return. Otherwise, I want to set a header for the content type. So I can call w.header, and I can execute that function .set. Now I want to make this content type, and then the content type is going to be application/JSON. And I also want to set a status code of 201 to say that we did create it. So I'm going to say w.write header, and this is going to be http.status created. And then I also just want to return my created short URL, and I need to encode that. So I can call json.new encoder, and I want to encode this into my response here. So this is named w.encode, and I want to encode my create short URL. Now, if we have a look at encode here, it does return an error. And if something returns an error, you should always catch it. So let's say error is equal to, and then we can just copy this block here. So if we do get an error when we try to encode the response body, we're going to return a 500 instead. Okay, so let's create a function to generate this slug. So at the top here, I'm going to say func generate slug. And this is going to return a string. So I want to say const char set is equal to, and this is just going to be all the characters that we can use in our slug. So this is going to be the full alphabet and all the numbers from 0 to 9. So I'm just going to paste that in there. So I also want to create a result variable, which is going to be a slice of bytes with a predefined size. So I want to say results equal to make, and I want to make a slice of bytes, and the size that I want this is going to be 6. So now I just want to loop through my result. So I'm going to loop through each character in this result, and I'm going to fill it with something random from our char set here. So for, I want to declare my index here, which is just going to be I, is equal to range of result. Now I want to say results I is going to be equal to char set. And then I just want to pick something here. So I need a random integer. So I can call rand.int n, and then I want it bounds to be the length of the char set. So I can call length of char set. So Go doesn't like this, and the reason is that we're getting rand from crypto random. We actually want this to come from the math package. So it's going to be math/rand instead of crypto rand. Okay, Go is complaining because it expects us to return a string, and return a string we will do, and that string is going to be our result. And we also need to wrap it in string because our result is otherwise a slice of bytes. Okay, so now we can make our slug equal to generate slug. And that's it for our create URL shortener handler. Let's go hook this up to an actual route. So before we do this, we need to create our short URL store. So I like to do this at the top here. So where we initialize all of these variables up here, I'm going to just say short URL store is equal to dbstore.new short URL store. And we do take one parameter here, and that's going to be our logger. So we can say dbstore.new short URL store params, and then we can pass in our logger here, and that is going to be equal to this logger up the top. Okay, so now that we have our store, let me just collapse these. We can create a handler. So I can say r.post /short URL. And we can say handlers dot new short URL. Sorry, dot new dot, and I think I may have named the new function incorrectly. So I've called this function new short URL store. It should actually be new create URL shortener handler. So it is new create short URL handler. Let's go back to our main function. And we'll call handlers.new create short URL handler. And we'll pass in some params. So this is going to be handlers.create short URL handler params. And the one param that we're going to pass in here is going to be our short URL store. And that is going to be equal to our short URL store. And then finally, we need to call .serve HTTP. Okay, let me close the sidebar here so you can actually see what is happening. So we're defining our route here, then we're defining our new function. Inside of that new function, we're passing some parameters, and then finally, we're calling .serve HTTP. The reason that you just pass this in as a function and don't actually execute it, this is the same as JavaScript, where you can just pass a function round as a value. That's essentially what we're doing here. We're creating a new instance of this struct, which has a function on it, and then we're going to pass that function in as a value to this post function here. Okay, so let's run this. So we can say go run. Okay, so we have this running. We need to stop this and run it again. If you get tired of stopping the server and running it over and over again, there is a plugin you could use called Air. I'm not going to show you that here because it's going to take a little bit of time to configure, but you can use Air to start the server automatically like you would with NodeMon or TSX, or even Node's new watch mode, for example. Okay, I'm going to open up my Thunder client extension. Then I'm going to post to port 8080, and then this is going to be short URL, and I'm going to have a destination here. And this destination is just going to be google.com. Okay, so we get an ID of 0 because of course the length of short URLs is 0. We get the destination and we get back a slug. Let's try to create another one. So our ID has incremented and we get a new slug. Create a few more. And you can see that this seems to be working perfectly. Okay, let's go add our test for this create short URL handler. So inside of handlers, create a new file, and this is going to be called create short URL underscore test.go. Now the tests always go in the package that they are testing. So this is going to be package, and the package is going to be handlers. And then we want to provide a function called test create short URL. Inside of this function here, we're going to have one argument, and this is going to be called t, and it's going to be a pointer to testing.t. So testing is just part of the Go standard library, which is awesome. It's great to have a great set of tools for testing built in. Then I'm going to create a slice of test cases. So I'm going to say test cases is equal to a struct. Actually, this is going to be a slice, so we need to put our brackets there. A struct, and then we need this second set of brackets because this is where our values are going to go, and this is defining the type. So the first one's defining the type, the second one is going to have our brackets. So our name is just going to be a string, and let's leave it at just that for now. Then let's define one test case. So inside of this second set of brackets, we need another set of brackets. So the TypeScript equivalent of this would be test cases is equal to a array, and then we have our brackets here, and it would have a name, which is test1. And then we would have a type here as well. So the type would be, let's say, name, and that's a string. So that's essentially what we're doing here. This set of brackets here is this set of brackets in your TypeScript code. So let's provide a name, and the name for this test is going to be create short URL successfully. Now we want to loop through these test cases and run a test. So I'm going to say for underscore test case is equal to a range of test cases. Then inside here, we want to call T, which comes from here. When we run this test, Go is going to run it and call it with this T function here as an argument, t.run. And then we need to name this. This is the first argument. So this is going to be tc.name. Then we provide a callback function. Instead of that callback function, we're going to get T. This is going to be a pointer to testing.t. So we have a new instance of our T function here. And then I just want to fmt.println. And this is going to be name. And then we can say tc.name. Okay, I get this little run button here. And I'm pretty sure I get that from an extension. And I'm not 100% sure what the extension is, but you may want to install this Go language support extension, and you'll probably get it from that. So we can click this button here, and then it's just going to run our test for us. Or you can click this button on the left, and it is going to give you a little bit more output. So you can see that we should get our name here, and our name is create short URL successfully. Okay, so let's add some stuff. So what do we want to do? Well, essentially we want to call our handler, and we want to call it with a certain set of arguments, and then we want that to call our create function in our store. So we're going to have to mock out our store, and we want to assert that it was called with a certain set of arguments. Okay, so I want to define a create mock result. So this is the result from our create store mock. And this is going to be store.shortURL. I want to have an expected status code, and this is just going to be an integer. I want to have an expected body, and this is just going to be a slice of bytes. I want to have a payload, and this is just going to be a string because we only define the destination. And I want to have expected create params. And this is going to be store.create short URL params. Okay, so the first thing we want to do is to create a mock of our short URL store. So I want to say mock short URL store is equal to a pointer to store mock. So it's going to be a pointer to mock short URL store. The issue with this is going to import the mock package. And so I want to rename this store mock to store mock. Now, instead of using this name mock here, we can say store mock.mock short URL store. And then we need to put some brackets there as well. Now I can say mock short URL store.on. So when a function in this mock is called, and that function is going to be create short URL, then I want to have tc.expected create params. So if our expected create params don't match the params that this function is called with, we're going to get a failing test. Now I can define what it returns. So I can say return, and I'll say tc.create mock result. And then we also return an error, and I'm just going to return nil for this error. If you want to test the error case, then add a property up here for our mock error, and then you can add that down here. Okay, so now I need to create my handler. So I can say handler, and this is going to be new create short URL handler. We need to call this with our params. So let's just grab that there. And this is going to take our store. And so we can pass in our mock store now. So you can see that Go isn't complaining, even though we're passing in something that isn't our struct. The reason for that is because in our params here, we're using this interface. So you can see this is an interface. And if we were using a struct, we obviously wouldn't be able to pass this other struct in because it's not the exact same thing. Okay, so now I need to create a request to pass into the handler. So I can say request is equal to HTTP test.new request. Its method is going to be post. That's the first argument here. The route is going to be /short URL. And then I want to pass in a body. So I'm going to say strings.new reader. And this is going to be tc.payload. And I also want a response recorder, and I want to record the response so I can make assertions based on what was responded with. So I can make an assertion based on the status code. So we can call this response recorder is equal to HTTP test dot response recorder. So this is going to be dot new recorder. Okay, so our handler here has one method on it. So we can call handler.serve HTTP. And our serve HTTP function takes two arguments. It takes our response, and in this case, we're going to pass in our response recorder, which satisfies the interface of whatever this serve takes. So a response writer. So we can see that response writer is an interface. And we can pass in request, which also satisfies the interface for our request object here. Okay, so we've sent off the request. Now we need to get the result. So I can say result. So let's call this response is equal to response recorder dot result. And we need to close the body, but we want to close it at the end. And to do that, we can use our defer function. So I can say defer response dot body dot close. So at the end here, we're going to close that body. Next, I can read the body. So I'm going to say body, and I'm also going to get an error. So I can call io.read all, and I can pass in the response.body. So I want to make my first assertion here. I want to assert that error is nil. So to do that, we need something called assert. So let's say assert is equal to assert.new. And we need to pass in t when we call .new. Okay, so now we can say assert.no error. And then we can pass in our error. So essentially, this is just going to assert that error is nil for us. Now we can make another assertion. So we can assert.equal and tc.expected status code is going to be equal to our response dot status code. And I also want to make an assertion based on this body. So I can say assert dot equal assert.json eq. So we're asserting that it's equal JSON. And we need to say string tc.expected body is equal to a string version of our body. Okay, so there's one more assertion we can make, and that is on our mock short URL store here. And this is going to say assert that all of these calls here that we're calling .on were actually called. So we can say mock short URL store dot assert expectations, and then we can pass in t. The reason we get assert expectations here is because this comes from mock.mock, and mock.mock comes from this testify mock package. Okay, so let's go fill this in. So our expected status code is just going to be http.status created. You could also just replace this with 201 if you want to, but I like to use the named versions. And our create mock result is going to be store.short URL. And this is going to be slug. And our slug is just going to be ABCDEF. And you'll see why we can do this in just a second. And then the destination is just going to be http google.com. Now my expected body is going to be a slice of bytes. And I'm just going to put an empty object in there for now because I'm lazy. I want to copy and paste this. And to do that, I can get it to throw an error. So I'm going to make my payload, and my payload is just going to be JSON, and the destination is going to be http google.com. Next, I want my expected create params. So these are the params that I expect create short URL to be called with. So that is going to be store.create short URL params. And we need a comma at the end here. We always have trailing commas in Go. So my destination is just going to be this google.com. Okay, so let's run this, and I'm going to run this with this little green tick thing here. So we're getting this error here because we're expecting this create params here to only be called with the destination. But if we have a look, you can see that it's also called with a slug. The problem is that creating a slug is just random. So it's going to change each time we run this test. We don't want that to happen. What we want to happen is we pass in a function that generates a slug that just returns a string that we define all the time. We can do that by passing in a function into the handler. So this is going to be called generate slug. And this is just going to be a function that returns a string. So we can call this generate slug. And again, it's just going to be a function that returns a string. Then we can say generate slug, and this is going to be params.generate slug. Now we can cut out this generate slug function. And now down here with our generate slug, we can call h dot. Then if we go back to our main function, we can pass in our generate slug function. So we'll just define this at the top. We need to import rand, which does come from math.rand. Okay, so let's grab that, and inside of our create short URL params, I'm going to say generate slug, and that's going to be equal to our generate slug function. Now with our handler here, we can define a function, and this function is just going to return 1, 2, 3, 4. Okay, so now we can say that we expect the slug to be 1, 2, 3, 4. Let's try this again. And we're still failing because the body isn't correct. Let's click this. And it's saying it needs to be valid JSON. So let's just go define what we expect it to be. So we expect this to have a destination, and the destination is just going to be google.com. And we also expect it to have an ID. It needs to be valid JSON, so it does need these double quotes here. The ID is just going to be 0. And then the slug is going to be 1, 2, 3, 4. So we're still getting an error here. And the reason is because we haven't defined a payload. And so it's not going to be valid JSON. So I can say payload, and this is just going to be backticks. And then we want to provide a destination. And this destination is just going to be our google.com. So let's try this again. And you can see that this test is now passing. So go ahead and add some other test cases here. So you can see that if you're going to add another test case, you'll just pop it in like this. So we can say that this one would be success. Then this one could be failure, and we could pass in something that won't pass. So let's remove the payload, for example. And we can say that the status is going to be status bad request. So you can see now how you could easily add new test cases. I'm just going to remove that one. So if you've made it this far in the video, well done. You should now have a pretty good understanding of how we can create the next route. So that is the route to do the redirect. If you want to pause the video and have a go of doing that route yourself, now is a great time to do that because I'm about to start. So inside of the handlers folder, let's create a new file, and this is going to be called get short url.go. And of course, this is going to be part of the package, the handlers package. And we're going to have a struct type get short URL handler, and that is going to be a struct. Then we're going to have a function, func new get short URL handler. This is going to return a pointer to get short URL handler. And then we're just going to return a new instance of that struct. We don't need any params on this for now. You may want to throw a logger in here, but I think a better approach to logging is to have some middleware to just log all HTTP requests. So we're going to have our serve HTTP function. So let's have a handler, which is going to be a pointer to get short URL handler. Then we're going to have serve HTTP. Serve HTTP is going to take our http.response writer, and then it's also going to have our request, which is http.request. So the first thing that we want to do is we want to get the slug out of the path. Now, there's probably a few different ways that you can do this. I'm going to do it the really simple way where I'm just going to remove the slash from the string and then just get the rest of the string. So the way that I'm going to do that is I'm going to create a new variable called slug, and we're going to infer the type and the value here, and we're going to say r.url. So we're just going to get the URL here, and then we're going to get path. So we're going to have a handler that is listening to slash slug. And we want to get this part here. We don't want to get this part of the slash here. So the way that we can do that is we can use this slice notation. So we can say 1 and then colon. And basically what we're saying is we're saying start here and then get the rest of the string here. So let's fmt.println, and we can print this slug so we can see that it is working. And we do need some params in our short URL handler. We need the store so we can get the short URL. So let's say type get short URL handler params. And I'm going to pass in our params here. And this is going to be get short URL params. And this is, of course, a struct. And we need to pass in our short URL store. And this is going to be store.short URL store, because remember, we want to use this interface so we can mock this out when we go to test it. Let's say our short URL store is store.short URL store. Now let's pass this in. Short URL store is going to be our params.short URL store. Okay, so now we can try find it. So short URL, and I think we passed in we returned an error here as well. So let's get that out. Is going to be our h.shorturlstore.getShortURL, and this takes one argument, and that is going to be our slug. So let's pass in our slug, and you can see here that we do return an error as well. So let's pass in the slug here. So say if error is not equal to nil, then I'm just going to say w.writeHeader, And this is going to be http.status not. I'm just going to assume that if we have an error, it's because we didn't find the short URL. And then of course we need to return here. Otherwise, if we do have a short URL, we can do a redirect. So we can say http.redirect. And then we can redirect. We need to pass in our response writer, our request, and our short URL.destination, and our http.status moved permanently. And we get an error here. Let's have a look at this error. Cannot use R, variable of type HTTP request, as a pointer to HTTP request value. So we just need the actual value here. So we can use this ampersand symbol to pass in the actual value, not the pointer value. Okay, so let's hook this up to a route. So under our route to create a short URL, let's say r.get, and this needs to be a GET request because the user is going to be making this request in the browser. And we need to put in our slug. And this is going to be handlers.new get short URL handler. Then we need to pass in our params. And this is going to be handlers.get short URL handler params. Inside of here, we need to pass in our short URL store, which is going to be an instance of short URL store. Then we need to call serve HTTP and not execute that. So we have an error here, and it's basically telling us that our request and our response writer here are incorrect. So let's go back and fix this. And you can see straight away that our request here isn't actually a pointer. So we need to change that. And then that's probably why we had this error down the bottom here. Okay, so now main is happy. Let's start this application up. Okay, so I'm going to go back over to my Thunder client here. And I'm going to create a short URL. Now I'm going to get one by a slug. And you can see that it has done a redirect here, and we get redirected to Google. So this is all working correctly. And you can see that we should print the slug here, and we do, and it looks all right. To make sure that it continues to work correctly, let's write a simple little unit test for this new get short URL handler. So I'm going to create a new file inside of my handlers, and this is going to be called get short URL test.go. This is going to be part of the handlers package, and I'm going to have func test get short URL. This is going to take t and a pointer to testing.t. Then we're going to have our test cases. This is going to be a struct, and we're going to have one property on here, and this is going to be name. Let's have one test case, and this is going to have a name of success. Let's keep this simple. Okay, so now let's loop through these test cases. So for, get out our index, get out our test case, assign the variables to a range, and then say what it is that we're going to range over. Then we're going to call t.run. We're going to pass in the name as the first argument. Then we're going to pass in a callback. The callback is going to take a new instance of the testing variable, which is testing.t. We want to create a mock of our store. So I'm going to say short URL store mock is equal to mock short URL store. And then let's rename this import as well to store mock, just so we don't get conflicts with the actual mock package from Testify. Okay, so let's create an instance of our handler. This is going to be new get short URL handler. This is going to take some params, which is going to be new get short URL handler params. And then we can pass in our short URL store mock here. And this L needs to be uppercase. So let's pass that in. And then this is going to return a pointer actually. So we need to pass in the actual values. So we can do that by putting an ampersand just before the store mark, or we could put that ampersand down here. But the problem is if you want to use that multiple times, you have to put the ampersand there. So I'm just going to put it up there where we declare the variable. So you can see that it's now a pointer to the short URL store. And if we remove that, it's the actual value. So we want to have a pointer there. So let's create our request. This is going to be HTTP test.new request. We're going to pass in a get. Then we're just going to pass in our tc.url. So let's add that to our test cases. So URL, this is going to be a string. And then we're just going to pass in nil for the final request, which is the body, because of course GET requests don't have a body. And I want to create a response now, and I'm going to use the response recorder so we can record that response. So I'm going to say response recorder is equal to HTTP test.new recorder. Okay, now we can call serve HTTP, which does the actual handler action.serve HTTP. We can pass in our response recorder and our request here. Okay, so let's get our response. So we can call this response, and this is going to be response recorder dot result. Then we need to close the body, and we can defer that with response dot body dot close. And let's just add an expected status. So I'm going to say expected status code, and this is just going to be an integer. Let's make URL all lowercase because we don't want to export it. It doesn't need to be public, and we need to keep the case consistent because it's an acronym. Okay, so let's make the URL /123, and our expected status code is going to be http.status moved permanently. Okay, so we need to mock the get short URL response. So let's say expected get short URL params is going to be store. Actually, this is just going to be a string. And then our expected params are just going to be this 123 portion of the URL. So let's say 123. And then we can say get short URL result. And then this is going to be a store.short URL. Okay, so now let's mock this out. Short URL store dot on get short URL. And then we're going to have our tc dot expected get short URL params. And then we're going to call return, and we're going to return tc dot get short URL result. Okay, so we need to put this in now. Get short URL result is going to be a store.short URL. And the destination is just going to be http google.com. Okay, so we just need to make an assertion based on the status code. So we also need to use assert. So let's say assert. And then this is going to be assert.new, and assert comes from the testify package here. So you can see we're importing that, and we need to pass in our t variable as well. So let's say assert.equal, and this is going to be our tc.expected status code. And then we're going to pass in our response.status code. Okay, so let's make an assertion based on the mock store as well. So we just want to assert expectations and then pass in T. So we're basically just asserting that it was called, and we're asserting that it was called with these params. Okay, so let's run this. And I have a problem with my mock. So I don't know what the return, because the method call was unexpected. Do mock.on get short URL. So it's telling us it called this thing from the mock store, but we didn't actually pass a handler for it. And that's because I spelt this incorrectly. So let's run this now. So we're getting this error when we run the test, and it's a little bit of a cryptic error here. So it cannot call get1 because there were 1 argument. This is referring to our mock. So you can see get1. If we have a look at our mock here, we are calling arguments get and then 1. So it's telling us there's something wrong here with this arguments of 1. If we go back to where we're using our mock, you can see that arguments 1 doesn't actually exist, and this is our error. So we need to pass nil in the error place. So let's try this again. Now we're getting another error here, and we're having a problem with the interface conversion because store.shortURL, so this store.shortURL is not short URL store. Again, this is an issue with our mock. So if we have a look here, you can see that we're trying to cast arguments 1 to a pointer to short URL store. So we need to change in our test this to a pointer, and then we need to say that it's a pointer. So let's try this again. And now this test passes because we get okay and we get pass. So let's handle the case of a 404. We couldn't find the short URL. So success, this is going to be fail with 404. And our status is going to be status not found. And we need to just pass a nil into get short URL result. Let's try this. So we get another error here. The issue now is if we go have a look at our short URL, so we're saying that if there's an error, then we're going to return the error, and that's fine. But the problem is we're passing nil in as the error argument. So there's never going to be an error. And then we try call short URL.destination, but this is a nil pointer. We passed in nil here. So destination obviously doesn't exist, and then Go just panics. So what we can do here again is if we can say if short URL is equal to nil, then we can just do this same thing here. The other thing we could do is we could put an error in the mock position, but I think it's good to just handle this case as well. So let's run this, and you can see that all these tests are now passing. So that is an introduction to Go. I really hope you enjoyed this video. If you watched to the end, let me know in the comment section below, and make sure you leave a thumbs up and make sure you subscribed so you get some more content from me. If you would like to know anything else about other Go concepts, also please let me know in the comment section below. Thank you for watching, and I'll see you in the next video.